Hi, I am Bernadette Venter Sefik, and I'm here with Katie Andre. Speak.
Hi, Andre.
And we are here to tell you, or I guess give you the definition of this question: what is light? So we will be explaining that to you. What is light? All right. So we're gonna the basics. Light. Light is a radiation of wavelengths, whether it's visible or not. Visible light ranges have numbers here. Visible light, what we as people call light, like sunlight, lamplight, light we used to see, that we do see, is on a range from what we call 380 to 780 nm. Alright, and then colors. Every color we see lies within a limited spectrum. And then there's the stuff that we cannot see, which is the radio waves. They have wavelengths in the kilo. I'm not really sure how to pronounce that, so I'll write that down. Kilometer range. And those are the ones that we cannot see. And yeah, alright, so that's base of light. Now, to break it down a little bit more, light exists of tiny, what would you say, packets, or like things packed in things together of what we call photons. They have properties of both wavelengths, of what the visible light, and then alright, here we go, visible light, and also the radio waves. So the ones that we can see and ones that we can't see. And so that is light is actually physically made of. So now that we have defined it basically, we're going to tell you the properties of light. Now there are, erase, oh balls, erase, there are 5 properties of light. Alright, 1. Intensity. 2. Frequency or wavelength. 3. Amplitude. 4. Polarization. And 5. Phase. Now, these are the 5 properties of light, and now we are going to explain those to you. Why don't you take on frequency, Katie? Go. Get frequency. Erase this.
Frequency often is not termed as a part of a wave, but it makes sense to introduce it in the section because we're going to be talking about wavelengths pretty soon here. So, and we had talked about wavelengths previously. So frequency, it refers to how often and how big, not usually how big, but how often light waves occur within a certain amount of time. Usually per second. For example, if if done by per second, they're usually described as cycles. So if you're monitoring a wavelength of light and a wave occurs every 10 times in a second, then obviously it's 10 cycles per second because it's occurred 10 times. So So yeah. So if these are our waves, sorry, it's upside down. I know that. And here's our graph. If this was a block of time, it's 1 second. There would be 4 cycles per second. So usually what we use is as for units is we use hertz to measure light. So it'd be 4 hertz per second. Yes. So Yeah, here is Bernadette with wavelength. Cool.
Yeah. Thank you, Peanut Gallery. All right. So wavelengths. We'll just write that at the top. Know what we're talking about. Wavelength. All right. So the wavelength is the distance between any two adjacent, so that means on either side, of two locations, as in like A and B, as in adjacent locations, on the wave. So let's just draw this. This is the equilibrium, which we are going to talk about later. Alright, go away! Sorry about that. So this is the equilibrium, which we're going to talk about later. But what we're talking about now is the wave, which is going to look like this. Appropriately named. I know. Looks like waves. So, as I said before, but wavelength is the distance between any two adjacent corresponding locations. So as in A, which is here, location 1, and location 2, which is adjacent part B. So so these are the adjacent locations. And so the wavelength is the distance between these 2 points. So this is a wavelength. Now, wavelengths can occur in any point on as McNeil doesn't believe, it's called wave train, but it totally is called the wave train. So, like, it can happen here, and it can also happen here, wavelength, here, wavelength. So really, that is what a wavelength is. Now, something else you want to know, wavelength, is the crest to next crest. So a crest and through is the section of the wave that rises above the undistributed positions is called the crest. So it's confusing, we'll talk about it. That section which lies below the undistributed position is called the through. These sections are labeled in, alright, so we'll just label this. Sorry, one second. I made a note to label this, so it makes more sense because I can't describe things very well. So, in simpler terms, when it says the crest is the section of wave that rises above the undistributed position, it's called the crest. So that is going to be all of this, crest. All of this, crest. And, as I said, the through is the section which lies below the undistributed. So this is above. And trough? Really? That's how that's pronounced? Trough. Through. Oh, that's true. Everything I know in life is wrong, Katie. Alright. So, trough, good gracious, is this thing. Trough. And this thing is for. Next, Katie, you want to explain amplitude? There you go. Explain here, hold on.
Alright, so amplitude can have a couple different meanings depending on the situation you're using it in. Its general definition is how much displacement there is in the most undisturbed position of the waves. So it usually goes from the medium to the top of the crest. So this right here can be measured out as the amplitude. There are, yes, and you should distinguish between positive and negative amplitudes. Like this would be a negative amplitude. If this is a graph, negative amplitude and positive amplitude. So, and you need to distinguish between those two because you need to know if you're talking about the wave or the crest or the trough. So, yeah, let me get my, hang on. Okay, and then Bernie wants to add to this, apparently.
So I know this isn't my part, but just to connect the ideas about the 5 properties of light. So here is our wave train, correct? So wave train. This is our equilibrium, which we're going to talk about in a sec. Now, so this is going to be the amplitude, correct? Now just remember that it corresponds with the, God damn it, this is going to be, it corresponds with the crest, and it corresponds with the trough, is how it's pronounced apparently. So to figure out, you know, if you're going to be doing equations and whatnot, which we didn't really get into because it doesn't explain light, but there's many equations about light, including like equilibrium, frequency, or whatnot. You are gonna need to know that these factors correspond with one another. So these 5 properties of light are all intertwined and whatnot for you to understand. You want to talk any more about amplitude, or should I talk about Here, you just speak.
So, to connect the ideas of amplitude, frequency, and wavelength, if I'm gonna erase this, not important. So we have our equilibrium. If we were to find the amplitude, the frequency, and the wavelength here, this is our wave. Or I'm sorry, crest to crest is our wavelength, or trough to trough, because in theory those are going to be equal. So that is our wavelength. How many times it occurs in the entire block of a second is frequency. In this case, it would be like 4. And the amplitude is however much there is in between. Basically how tall and how deep the waves go. So these are just several ways to define length and waveness. So here is Bernie with the next stuff.
So our last one in describing light to you is the equilibrium, which we have mentioned quite a few times before because it is important. So in all these diagrams, you're going to look about the same. You have your wave train, correct? And your crests, and your troughs, and your crests, and your troughs, and your wavelengths. But what's very important is the equilibrium, which goes straight down the middle. Now, that is determining, you know, your amplitude, how far from the equilibrium. It is determining your crest, in that, is it above equilibrium, or is it a trough below the equilibrium? So, and the frequency. So really, it's in the equation, whatever you're trying to find out. Now, hold on, I'm trying to think of my thoughts. Now, how do I explain this? What's a good example? Zero. It's a good one. Like, if this was a graph, you are on line X, or 0 on the X line. Oh, here's a good idea. Okay. So think of the equilibrium as a rope. Now, equilibrium would look like this. No photons, light emitting whatsoever. Your wavelength is going to look like this. The equilibrium is going to be all that exists. Now, light is like shaking the rope. So you're making the rope go up and down, right? So light essentially is shaking the rope, and the equilibrium is the rope. You can't really see this on the map, can you? I'm sorry. Okay. On the screen, sorry. Anyways, so yeah, hope that makes sense. Sorry, we've been rambling here for 15 minutes. Wow, all right. All right, so hope you understand light and its 5 properties now. Congratulations! Thumbs up! All right, we'll be here all week. We appreciate tips. Good night.